a series and we have data frames, and earlier we used to have a third data structure. So do you guys know what is the name of that data structure? I believe I asked you guys to explore about it. So do you recall, or do you now know what was the name of that third dimensional data structure in Pandas? Himanshu, how data frames are 3D structures? Can you explain? So earlier, pandas used to have a structure by the name of panel. Yes, Paras has rightly mentioned it. So that data structure was a 3D structure, and currently you can kind of make a resemblance to that structure by using the concept of multi-indexing. So please have a look at what this concept is. So there is a function by the name of multi-index. Please explore in tomorrow's class. I'll also talk about it. Now, the second question that was asked in yesterday's session was related to indexers. So we uh, talked about three indexers, iloc, loc, and add. These two were used to perform indexing, and they were used to also implement slicing in data frames. Add is used to index something out and also change its value. So I asked what is the major difference between iloc and loc, because we didn't study about it yesterday. So do you guys now know what is the major difference between the two? Yes, guys, do you know what is the difference between iloc and loc indexes? If you don't know, give me a thumbs up so that I have a clue. Yes, so Himanshu has correctly mentioned that loc is used for label indexing and iloc is used for number-based indexing. So if you have indices in form of labels and you are trying to achieve uh, if you are trying to index something out using both of these indexers. So loc can be used with labels, but iloc necessarily requires an integer key. Okay, so this is something that is mandatory for iloc. All right, please give me a thumbs up if everything is good to go and we can carry on with the session now. Okay. So let's start by uh, learning about joining, merging, and concatenating data frames. So although on the surface, three of these words, they are quite similar. All of them means that we are appending together the data frames. However, when we talk about conceptually, so there is a slight difference between merging and the other two. So let's figure that out. So I am going to start by creating a data frame using NumPy. So let's import the two libraries and let's create a NumPy array and let's use a function. So I am going to use np.random.rand int function. Let's give a range. So I'm going to give a range from 0 till 100. And since this function can also take the shape, so I am going to make it a 3 cross 4 array. This is going to be array 1 and I can directly transform it into a data frame. So let's use pd data frame function. And let's also give some column names to it. Okay, this is going to be df1, and let's create another data frame. The dimensions are going to be same. The shape is going to be same, that is 3 cross 4. I'll simply make some changes with the column names. So here instead of B, let's have a column E and F. Apart from it, everything is same. Let's have a look at how the data frame looks like. So this is df1 and this is df2. You can see that some of the rows, some of the columns, they are matching, whereas E and F, B and C, they are the unique columns in both the data frame. So let's start performing concatenation using concat function, and this is very similar to what we did in arrays. So you can perform concatenation using pd.concat, and inside a list or in a tuple, pass the data frames that you would like to join. Okay. So if you have 3 data frames, you can very well pass the third one, fourth one, and number of data frames that you have. If you use this function as is, so you are going to see that these elements, the concatenation or the join that is performed, this is row-wise join. Till here, you can see these are the rows. The first rows, they belong to my first data frame. And these rows, starting from here, they belong to my second data frame. So a row-wise join has taken place. Wherever the value was not present, since E and F columns are not present in data frame 1, I can see that NaN is written there. NaN basically means not a number, or it is a null value, to be very specific. All right. Here, if you read the docstring of concat function, you are going to see that it has a parameter that is access, and the default value is 0. So again, just like in case of NumPy arrays, you can use that access parameter to change the type of concatenation. So if I change the value of access and put it to 1, now you can see that a column-wise join has taken place. These are the columns A, B, C, D of first data frame. A, E, F, D are of the second data frame. All right. Please give me a thumbs up if you guys now know how to use this concatenate function. Okay. Now we have another function that is append, and this is known as a very specific case of concat function. So let's see what do we mean by this specific case. So if you want to use the append function, you can write it like so. So mention your first data frame, use the append function, and pass your second data frame as the argument. You can see that it has done pretty much the same thing that concat was doing when access was equal to 0. And that's why append is known as the specific case of the concat function. Okay, I believe there is no doubt, and you guys are able to differentiate between the two. Let's talk about merging now. So this is third kind of concept that you can use to join two data frames together. Now merging takes place based upon common values only. Okay, so when your data frame is going to have, when two of the data frames, they are going to have a common value, only those values will be merged together. Let's see what I mean by this. So I am going to create another data frame, and let's create it using a dictionary. So it is going to have a column A, and let's provide some values. And a column B. Let's create another data frame. And what I'm going to do, I'll keep this red value same, but I'll change blue to some other value. And let's also change this column name. So now I got two data frames. Let's call it A1 and A2. This is how they look like. Now, one thing that you can totally observe here is that 0th row and 8th column has same value in both the data frames. So if I merge them together using the merge function, what do we observe is that the other rows, that is the one with blue and the other one with green, they do not get mentioned in the resultant data frame. Only the value that was common, which was red, for that I have a new column appended to it, which is C. So this column, which was not present in A1, that column got appended with the common value of both the data frames. Okay. A1 dot merge A2 means merging A2 with A1. All right, please give me a thumbs up if you guys have a clear idea about it now. Okay. Now we are going to see some of the specifications of this merge function. Okay, and for that, I am going to show an image to you guys. Okay. So these are four kind of merging operations or joining operations which can be performed on Pandas data frame. Just like we have these kind of operations in databases, so they are quite similar. We have a left join, right join, inner join, and an outer join. You can look at these Venn diagrams to understand, to have an overview about what these operations they mean. And we are also going to explore these based upon some data sets. So what these operations do, based upon common values present in the left data frame, it is going to join the two values together. The right join, based upon the values present in the right data frame, it is going to join the two data sets together. Inner joins are performed based on the common values, and outer joins are performed based upon the based upon all the values that are present in both the data frames. So the append and concatenate function, it is quite similar to what we had in NumPy arrays, whereas the merge and these joining operations, they are similar to the queries that are made in databases. Okay. So let's figure out how these different type of joins they can be performed. So for that, I have three data sets. I'll show them to you. And these data sets you guys can use. I have provided them in the drive as well. So we are going to use diabetes data 1, diabetes data 1 new rows, and diabetes data 2. Okay, if you are coding along, I would recommend to download these three data sets. All right. So let's start by reading the first data set. And let me just get its name. Okay. Now I'm not going to simply import it as it is. You can see that here I have a column that is patient ID. I'm going to set this column as the index label for this data frame. So either I can use the set index function that we studied yesterday, or I can use the parameter here, that is index underscore call, and I can mention the column that I would like as my index column. So it is as simple as this. This is our data frame 1. Let's call it dia 1. All right. And let's print a few records of this particular data set. Now, if you look it as a whole, you will see that it contains patient ID starting from 001 and it is going till 020. And I want to keep a note of the patient IDs in different data frames. All right. If I display the shape of this data frame, I get to know it contains 20 rows and 4 columns. Okay, this is my data frame 1. Let's import second data frame. So this one is called diabetes data 1 new rows. Let's change the name. Okay. And this one contains patient ID from 22 till 26. Let's check its shape. So the shape of this particular data frame is 5 cross 4. Now it's time to import the third data frame, which is diabetes data 2.csv. Okay. Now, if you can see, this one contains 2 columns, which are BMI and age. These columns, they are not present in any other data frame that we have so far imported. Not in data frame 1, neither in data frame 2. The other thing that we observe here is that patient IDs from 1 till 5, these IDs are present in data frame 1 and patient ID 21 and 30. I guess they are not present in either of the data frames. Okay, so you can see some part of the data is common between all of them and the rest of it is different between all of them. Let's print the shape as well. So the shape is 7 cross 2. Now let's start with the joining operation. So we are going to proceed with left join. The function is simple, that is pd.merge, and left right in these kind of joins, they refer to the uh, sequence in which you provide the data frame values. So I want data frame 1 to be my left data frame and data frame 2 to be my right data frame. Okay, and that's why I have mentioned them in this specific order. There is a parameter, that is how, in which you are going to mention the kind of join that you want to perform. And I want to perform left join. The fourth parameter is going to be what should be the key based upon which the join must be performed. Okay, so here I'm going to use patient ID as the key. Okay, and let's perform the join. Just give me a moment, guys. Okay, let's see it with data frame 3 because here is the original change that we will observe. Yes. Okay, so here what you guys can see is that the column BMI and age, that was not present inside data frame 1 and it is only present in data frame 3. You can see that the IDs that I get in my resulting data frame, these are the IDs which belong to data frame 1. So when we say that the left join is performed based upon the patient IDs that are present in data frame 1, we mean that all the IDs of data frame 1 will be present in the resulting data frame. Okay. You can see that till 20 we have all the IDs, and none of the IDs, okay, like here we have 21 and 30. These IDs, they are not present inside data frame 1. That's why they are not also present in the resulting data frame. You cannot see 21 or 30 anywhere written. For the IDs that are common between both the data frames, you can see that all the values are present for pregnancy, glucose, and these columns, and for BMI and age as well. But these values, since these IDs are not present in third data frame, they get filled with NaN values. Give me a thumbs up if you are able to observe what I'm intending to say. Okay, let's repeat once again. So you can see patient IDs from data frame 1, that is on the left hand side. The join is performed based upon these, and the IDs that are only present in data frame 3, they get ignored. If you check the shape of this data, let me just copy it. So you can see that the shape is 20 cross 6. If you recall, the shape of data frame 1, it was 20 cross 4, which means that no new row has been added, but 2 new columns are added from data frame 3. Okay, this is the observation that we got at the end of it. Now let's perform right join. Okay, so if I use these two data frames only, the key is also the same, but I change the method of joining and convert it into right join. Here you can see that the patient IDs which were present in data frame 3, they are mentioned. Even 21 and 30 are here. Okay, because right now we are performing right join, so the keys from data frame 3, which is on the right side, they are going to be given preference. If you will check the shape is 7 cross 6, which means that no new rows are added to data frame 3. Okay, all the rows which were present in data frame 3, they are only included. All right, please give a thumbs up if you get what right join is. Okay, great. Now let's check about inner join. So inner join is going to be performed based upon the common IDs between both the data frames. So we know that patient ID from 1 to 5 are present in both the data frames. So I can expect that the shape or the number of rows in the resulting data frame, they are going to be 5. So these are the 5 rows because these are the common IDs between both of these data frames. And if you check the shape is, well, 5 cross 6. Okay, so this is inner join, which is happening on the based on the common keys. Okay. This brings us to the last kind of join, that is the outer join. So the outer join, it is going to be uh, taking all the IDs based that are present on both of these data frames. Okay, it is kind of a union of all the patient IDs. You can see patient 1 till 20. These are from data frame 1. Then data frame 2, data frame 3, it already has these IDs, and the unique IDs which are 21 and 30, they are also present. So if you check the shape is 22 cross 6. Okay, which means just 2 new rows, they get appended as they were not a part of data frame 1. Okay, they were unique to data frame 3, which we were not able to observe in left join. All right, give me a thumbs up if you guys know a clear distinction between these four kind of joins. Okay. All right, so let's take a 2-minute break. And after that break, we are going to proceed further with the session. Maybe we can solve a question or maybe we can explore other concepts. All right, a 2-minute break. All right, do we have everyone here? Give a thumbs up if everyone is present. Okay, guys. So let's understand a few functions which are quite important to get to know more about your data frame. Okay, so we are going to start by checking for null values and how to handle them. We can take this data frame that we got and let me call it diabetes. Okay. So if you want to check for null values, there is a very easy function that is null. And let me just run it. Yeah. And what this function is going to do, it is going to return true at the places where a null value or a nan value is present. And every other place you are going to see false. But in a very large data set, it is quite difficult to spot a null value. And if there are very few null values, it is going to be even more difficult to spot them. Identifying null value is very important from the aspect of machine learning because your model is not going to train properly on a data frame which contains null value, even if one single value is present. So if I want to just know altogether how many null values are present in each of the column, so I can use the dot sum function upon the isNull function, and then it is going to calculate for each column how many null values are present. Okay. So comparatively, it is easier for me to observe and to understand about the constitution of null values in my data frame. All right. Now, based upon how many null values are present, you can take different course of actions. You can either drop them, or you can either fill or impute them. Okay. Dropping simply means that if there are null values, simply drop the data. Okay, delete the data from the data frame. Filling or imputing means that instead of that nan value, you are going to provide a new value from your side. Okay. So let's see what filling means first. if I have the data frame which is diabetes, so you can use a function that is called fill any. And instead of the null values, I want to mention, let's say, 0. Okay. So you can see that wherever a null value was present, I get 0 written inside my data frame. Okay. So if you want, you can fill your null values with any equivalent value. But this is not a right practice or a correct practice. Okay. I cannot say that 0 is the representative of all of these values. Basically, I'm being biased towards one particular value, which shouldn't be done while dealing with data on which you want to train your machine learning model. So fill NA, it has various other different parameters that you can use, and you can even use it in various ways. So one way, or if I must mention that the correct way to fill any particular NaN value, if there are numerical values in that particular column, then I can say that it would be better to fill these null values with the average value of all of these columns. Sorry, of a particular column, or with the median value. If it is a column of object data type, maybe I want to consider the mode of all the values. So at least I am being biased towards a specific value, and I am following a particular manner to do that, not blindly relying on one single value, which has no relevance in my data set altogether. Okay. So what I want you guys to do, I want you to explore how to use fill any to fill the data frame with the mean of a particular column. Okay, quite easy. A simple variation to this function would achieve that. Now, what do we mean by imputing? We are going to learn about imputing when we will explore data pre-processing just before learning about machine learning. So I would ask you to ignore it. And if you find any function to impute the null values, okay, because when you are going to search to fill null values with mean, you might also find a function for imputing. So you have to ignore it, just simply explore this fill any function. Okay, so this is one way to do this. Now, if there are only one or two single values are present, okay, so in the data set, where did we check for? Yeah, here. You can see that the pregnancy, glucose, diabetes, and pedigree function, they are containing two null values each. All right. So where null values, they are present in like minimum numbers, you can drop these null values. But if you find a column, okay, which contains a larger number of null values, it is not mentioned, or it is uh, not specified to remove these values, as it is going to result into a loss of data. Okay. So if you have larger number of null values, you are required to fill or impute it. And if you have smaller number of null values, you are required to drop them. So let's learn about dropping. Okay, there is a function that is drop any. And what this function has done, it has dropped all the null values. If you have a look at it, if you have a look at the data frame, you can see that the original data frame, it still has the null value, because I told you that most of the functions of pandas, they do not change the data frame altogether until and unless you specify a parameter in place and set it to true. Okay. The most significant change that I want you guys to observe here is that using the drop NA function is going to drop all the values, all the null values from all the columns. And as a result, you can see that the resulting data frame, it only has 5 rows, whereas altogether I had almost 22 rows inside my data frame. So you can see that how it has affected, how it has resulted into a loss of data altogether. Okay. So what I want you guys to do, I want you to learn how to remove null values from a specific column. Okay, so that not all the columns are affected by it, and very easy to do it. Just explore it on your own and tell me about it in the tomorrow session. Okay, so when we mention in place equals to true, you can see that the changes they get reflected in the original data frame as well. All right. Is there any doubt regarding any of these two functions that I have used, fill NA and drop NA? Give me a thumbs up if everything is crystal clear. All right. Now the fill NA function. Okay. I guess we used a data frame. Let me redeclare the diabetes data frame so we have some null values. Here it is. All right. The fill NA function that we talked about, it has a parameter that is method. Okay. And there are basically 4 different kinds of method that you can use. So we have bfill or backfill, and both of them they serve the same purpose. And then we have forward fill and pad, and these two methods they serve the same purpose. So bfill and backfill, forward fill and pad. Let's specify bfill as the method type and see what do we observe. Firstly, let me just show you how the data frame is looking like without it. Okay, so we can see that we have lots of null values right here present. If I use bfill here, so bfill basically means backward fill, and I guess the null values they were starting from here. So what has happened that all the null values they got filled, yeah, they were starting from here. All the null values they got filled by a value that is present just before them. So in a way you can say that these values they got dragged to the columns just after them. Okay, so this is what we can conclude by bfill or backward fill. And you can provide any value, either this value or this value, it is going to serve the same purpose. In a similar manner, please explore ffill and pad and observe the change in your data frame. They are going to fill your data frame in a forward manner. So let's take an example. If here we have the last value and all the values above, they are of NaN type, then it is going to fill them with these values from bottom to the top. Okay, so this is forward fill or ffill. I believe there should be no doubt with forward fill, sorry, with backfill. Can you please give me a thumbs up if you understand what backfill is? Yes, guys, please give a thumbs up if you understand what backfill is. अगर नहीं समझ में आ रहा है कुछ तो you guys can mention in the chat box as well. Okay, it is not compulsory to like agree with everything that I say. Okay, Modhwaj is asking 25.6, where is it coming from? Let me show you. Where is 25.6, Modhwaj? All right, so sorry, I reversed the concept. These are the values that are getting filled. Okay, from backward fill. So in the bottom, you can see that we have these two values. I completely forgot about it. Okay, so please explore backward fill and forward fill. So these were the values which were getting copied and which were dragged all towards the up upper section of this column. Okay, before concluding, we are going to explore one last concept, that is filtering, and then I'll provide you guys a question. So for filtering, I am going to read data frame iris, and I'm going to store it inside a variable. Okay. So we had a look at this data set yesterday as well. And today we are going to explore it and we are going to learn what is filtering using this data set. Okay, as the name suggests, you are going to filter out some values based upon some conditions. So let's say I have a requirement where I want to get all the records with a specific sepal length. Okay. So firstly, let's observe what all different values are present inside sepal length column. So yesterday I taught you that you have a function that is unique, which tells you all the unique values in a column. So we have values ranging from 4 till 7.9, I guess. Yes, so somewhere around 4.3 to 7.9, these values are ranging. Let's say I only want those records, okay, which have sepal length greater than 7. All right. Sepal length greater than 7. So what I am going to do, let's fetch the column first. So here is the sepal length column. Okay. And I'm simply going to mention here the condition that is greater than 7. So what do you guys observe? You see that I get Boolean values. False is written at the places where the sepal length is not greater than 7 centimeter. Okay, you can see most of the records. Okay, most of the values, they are lesser than 7. But this is not what I require. I want to see the records in actual to which are satisfying this condition. So what you are going to do, you are going to mention square brackets on either of the side, and you're going to pass this condition as a subscript to your data frame. Okay. First I wrote this condition, then I passed it as a subscript to the data frame. And what do we observe here? I observe that we have these records where the sepal length is greater than 7 centimeter. All right. If I use a function that is count, it is going to generate a count of all the rows which are present. So there are 12 rows which are present in this particular section of the data set. Okay, so 12 records which satisfy this condition. What if we have multiple conditions? So you can see that sepal length is 7.1 centimeter, and you can also see that there is a column about sepal width, let's say. Let us first observe what are the unique values for this column. Okay. Now, sepal width, it is ranging somewhere from 2 to 4.4. Okay, this is the maximum value that I can observe. Obviously, you can use the max function and min function to know about the range of values. So from a rough idea, I can see that this is the range starting from 2 to 4.4. Let's say I only want those records which have sepal length greater than 7 and a sepal width which is greater than 3. Okay, so this condition, it is the same. Sepal length greater than 7 and sepal width greater than 3. So how can I write multiple conditions now? Please observe carefully. Firstly, you guys can get the sepal width. Till here, we know everything. We can use this concept to access the column. I can put greater than 7 and I would have a clue that these are the values which satisfy this condition. Let's do the same with sepal width as well, but do it in a different cell. For the sepal width, the condition is 3, and for sepal length, it is 7. Okay. So what I have done, I have individually mentioned these conditions. This is for sepal width, this is for sepal length. I want to satisfy both of these conditions. So I need to use an operator, and that is the AND operator. So let's merge these two things together. To separate them, I'm going to use parentheses. This is the first condition and this is the second condition. And we are going to join both of them using an AND operator. If you run it, you are again going to observe set of Boolean values. But these Boolean values, they are based upon satisfying both of these conditions, which means sepal width greater than 3 and sepal length greater than 7. To get the records, you can wrap it inside square brackets, mention it as the subscript to the data set. And these are the 4 records which satisfy this condition. Okay, sepal length greater than 7 and also sepal width greater than 3. Please give me a thumbs up if you are understanding how to filter your data frame based upon multiple conditions. If you have a third condition, okay, you can mention it as well, include it with the operator. All right, you can check for equality, for greater than equal to, that completely depends upon you guys. All right, I believe there is no doubt related to it. Now let's say I want to drop this data. Okay, maybe according to my requirements, this is the data that I don't require at all in my data set. So how to drop it? Firstly, I am going to store it in a variable. Let's call it not required. Okay. Then to drop any particular record, we have a function that is drop. And here you are going to mention the index values of the record that you want to drop. So not required are the records which I want to drop. And if I use index attribute upon them, okay, so this is going to pass the index of these particular records. If I check the shape is 146 cross 6. The shape of the original data frame, it was 150 cross 6, which means these 4 records, they are not dropped from my data set. Okay, but in original data set, no changes would be made. So again, you have to use that in place parameter. Let's use it. Okay, and now those records which were not satisfying your requirement, they are dropped from the data set. Okay, this is how you are going to drop any unwanted value. Okay, any unwanted record. Give me a thumbs up if you understand everything till here, and then I can give a question to you guys. All right. So here is an activity for all of you. You have a data set by the name of player.csv in the drive. Please download that data set. It is, I guess, a very small data set of 15 or 10 records only. Once you download it, you have to remove data of players who did not score a single century. You have to replace the name of V. Kohli with Virat Kohli. You have to, okay, these 4 things are going to be the homework, The third and the fourth point are going to be the homework, and these two things you have to do right now. Okay. Anyone who is attempting, give me a thumbs up. Okay, Modhwaj is attempting. Anyone else? Paras is attempting. Also Imanshu. All right. Good luck, guys. Two very easy questions. Do it and let me know. Well done, Himanshu. Himanshu has solved the second question. Are you solving first one as well, Himanshu? Okay. Paras has also attempted the first question and it quite serves the expected result. Okay. You can also do it using the drop function as well. Himanshu has mentioned the same. All right. I guess you guys have figured out different ways to do it, and it is quite impressive. So I'm going to mention Himanshu's answer as well. Please be careful with the data frame name. Okay, I'm not going to change it. You guys can, when you're going to have a look at the notebook, please see that this is also a way using the query function and the drop NA function to drop. All right. So with this, we are going to end the session. Question 3 and 4 are a homework. Along with one more thing, please explore these two functions, duplicated and drop duplicates, since we are running out of time and this week also has a holiday. So please explore these two functions. And these are the two questions and also a few of the things that I mentioned between the lecture. Okay, thank you guys. If you have no doubts, you are free to leave the session. If you have any doubts, please stay and please discuss.